So in this video we're going to solve some simultaneous equations. That means finding a value for x and a value for y which will satisfy both of our equations at the same time. Now if we just had one equation we wouldn't be able to do this because say we look at 2x plus 2y equals 12, there's actually an infinite number of solutions that you could have. You could have x is 3 and y is 3, you could have x equals 4 and y is 2, you could have fractional answers as well, and so it turns out there are just an infinite number, and that's not very useful for us to sort of think about. So having two equations makes all the difference and allows us to narrow things down to just one pair of values which will satisfy both. Now there's a standard procedure for dealing with equations like this. What we do is first of all label the equations 1 and 2. That's going to help us think about what we're doing and allows us to describe to someone else how we're doing it. And I've set it out so that it looks a bit like column addition or subtraction, with the x terms above each other, the y terms above each other, and the numbers at the end there. And that's what you need to do every single time. I'm going to draw a line because what we're going to actually do is something very similar to column addition or subtraction. We're going to be actually subtracting these equations one from the other, because say 2x plus 2y, that is smaller than 5x plus 2y. In fact it's smaller by an amount of 3x. But to make it easy to think about, we're just going to do it in columns. So if we do 5x take away 2x, that gives us 3x. 2y take away 2y, well that's nothing. And that's exactly why I've chosen to subtract these equations. 18 minus 12 is 6. What we've ended up with there is just one equation with just one variable for us to find the value of. And we can do that. We know how to solve this equation, 3x equals 6. We know that we just need to divide by 3 and x is worth 2. So when you've got an equation with just one unknown variable, you can solve it no problem at all. You've done that before. But when you have one equation with two unknown variables, you wouldn't be able to do it. So the key thing is to eliminate one of the variables in this sort of process of adding or subtracting the equations together. Here we subtracted, and that was because we had a plus and a plus 2y. So we had to kind of think about it beforehand. I had to look and say, oh, I've got 2y and 2y there, and so that's how I made my decision to subtract. Going back to this result, if we know x is equal to 2 here, well, we can then find what y is by substituting back into one of the original equations. Say I look at equation 1. I know that 5 lots of x, which is now 5 lots of 2, which is 10, plus 2y must equal 18, and therefore 2y is worth 8 if you take away 10 from both sides. And finally y is worth 4. So our solution is x is 2 and y is 4. Now there's one extra little thing I'm going to do on the side which I should have done earlier, and that is I need to write that I've done equation 1 take away 2 on the side here. It's very important to show your workings on the left hand side and explain what you're doing. That's potentially worth method marks.